This is an example of a normal distribution of golf scores, and we're going to go ahead and use the graphing calculator with one variable statistics to find out some percentage problem. So we want to find out what will be one standard deviation from the mean if we're giving these golf scores. So let me read it to you. From 1984 to 1995, the winning scores for golf tournament were as listed: 276, 279, 279, etc. They're not in numerical order, which is fine. We know that when you take it and put it in your graphing calculator. What we're going to find in the graphing calculator is your standard deviation and the mean. And we want to figure out the question, what percent of these scores fall within one standard deviation? So I don't care about if we go up to 2 standard deviations, 3 standard deviations. So I'm going to go ahead and bring up my graphing calculator. So I'm going to scroll this over for a minute. And I'm going to go ahead and start my graphing calculator stat. So push stat. Then you want to make sure it's an edit, which already is, so enter. We're going to scroll up to the top, clear, and delete our list out. Now we're set to enter in our list. So after each item, you're going to go ahead and enter. Push enter every single time. 276, enter. 279, enter. 279, enter. 277, enter. 278, enter. 278, enter. 280, enter. 282, enter. 285, 272, 279, and 278. All right, make sure you push that last enter. So we have 12 scores entered in. Now, we're going to go ahead and push the stat button again. We're going to arrow over to calculate. We want one variable statistic, so go ahead and push enter. Now it's going to ask us to call up the list. We were in list 1 in our previous screen. So how you get to list 1 is you're going to push second and the number 1, and then enter. Now we can see the 2 values that we need. The top score there is your mean, 278.583 repeating, and then the S of x, which is our standard deviation of 3.1466. So those are the 2 numbers we're going to use. So now I'm going to bring my slide back over to continue with our problem. So I'm going to write down those 2 values. So again, the mean and the standard deviation is what we need for our normal distribution. So our mean was 278.53, and then our standard deviation, which was the S of x in the calculator, was approximately 3.14. Now I'm going to head down to my normal distribution curve. Create my middle, my mean. So my mean was 278.53. Now we only have to worry about 1 standard deviation to the right and 1 standard deviation to the left. But we only want the scores that fall in there, and what is the percentage. So if you remember how to find that, we have to add 278.53 plus our standard deviation of 3.14. And that'll give us our positive standard deviation. Now I'm going to head over to the left. We're going to take 278.53, and we're going to minus the standard deviation of 3.14. And that'll give us our left of our standard deviation. So this value here is 281.73. And then this one is 275.43. I'm going to go ahead and write those down here. So 281.73 and 275.43. So we're looking for values of scores that fall between approximately 275 to 281. So now let's head back up and count how many scores fall in there. So we're looking for 275. So 276 would fall. 279, 279, 277, 278, 278, 280, 282, that one is too big. 285, too big. 272, too small. 279, 278 fall within those scores. So we add up how many we have in the blue. There are 9 out of a total of 12. So we need to figure out what is the percentage. How many scores fell in that one standard deviation? So we have a 9 out of 12 total scores, which reduces to 3/4, or as a percentage, 75%. So that is the answer we were looking for.